Hello and welcome to this Tungsten Cluster Masterclass training session where we take a deeper look at multi-cluster topologies, specifically Composite Active-Active. My name is Chris Parker, VP of Customer Success here at Continuant. In this session, I will start by reviewing what the Composite Active-Active topology is and how it works. I will discuss any additional considerations and review the configuration files to build the topology. I'll finish with a demonstration of the topology being installed. So what is the active-active topology? So active-active extends the concept of the active-passive cluster, but introduces multiple writable endpoints. In this topology, you would have at least two clusters consisting of the same minimum requirements of a 3-node per cluster or 2 nodes and an active witness. Both clusters, however, are active, and each cluster has a single primary node and 2 or more replica nodes. The underlying bidirectional cross-cluster communication is handled by a subservice that handles the replication from each cluster to one another. The connectors will ensure all the right traffic is sent to the active cluster that the connector is primarily associated with, and reads will be distributed based on the rest of your connector configurations. Failover between nodes within a cluster is automatic, but should the active cluster fail completely, providing the connectors are still available on dedicated hosts, they will route read and write traffic to the next available cluster. In a multiple cluster configuration, this routing can be configured to prefer a specific cluster over another. So, for example, if you have 3 clusters with 2 of them situated in the US and 1 in Asia, you can ensure that should one of the US clusters fail, it routes to the other remaining US cluster rather than the Asia cluster. So what are the configuration considerations? As with a standalone cluster, all the usual prerequisites that we covered in our earlier sessions need to be in place. For network connectivity, not only do you need to ensure local cluster nodes can communicate, but you also need to ensure they can communicate across regions with the other clusters. This could have additional security considerations within your organization and should be handled accordingly. A full list of the network ports required are listed in our documentation. There are additional THL ports required for an active-active topology. The default port for all clusters is 2112. With each cluster that gets added, the additional port would increment by 1. So, for example, if you have 2 clusters, you would need to make sure that 2112 and 2113 are open. For 3 clusters, 2112, 2113 and 2114, and so on. To ensure consistency in replication, it is also mandatory that your binary logging in MySQL is set to row-based logging. You need to ensure that the network latency between clusters is adequate to ensure timely replication. Whilst we do not have a documented minimum latency expectation, you should be aware of the implications of high latency. In an active-active deployment, tungsten clustering does not include built-in conflict resolution. This is an intentional design choice. While conflict resolution is often requested, implementing it generically across all use cases would add significant complexity to the replication and reduce reliability. The reality is that conflict resolution rules are highly application specific. Different organizations and even different tables within the same application can have unique business logic governing what constitutes a conflict and how it should be resolved. Trying to enforce a single system-wide conflict resolution model would be both error-prone and inflexible. Instead, we focus on conflict avoidance as the best practice. There are several key strategies to minimize or eliminate the risk of conflicts. So we have sequence number offsets. So in your MySQL, configure the auto increment and values. Use unique offsets across ranges of clusters. This prevents collisions where 2 clusters might otherwise generate identical primary keys for different rows. The application level partitioning. Design your application so that data changes are routed to specific clusters based on logical boundaries such as geography, customer region or schema. This approach, often called geofencing or schema level separation, ensures that updates for a given dataset are always handled by a single cluster. And then operational discipline. So avoid scenarios where the same records can be updated concurrently in multiple clusters. Enforcing clear ownership rules for data domains is critical to maintaining consistency. It's also worth noting that active-active topologies are not suitable for every application. Applications that rely heavily on shared mutable data or lack partitioning logic can encounter synchronization challenges. In those cases, an active-passive design might be a more appropriate and reliable choice. In short, tungsten clustering provides the framework for active-active operation, but it relies on intelligent application and data design to ensure conflict-free replication. Finally, connector behavior. All connectors will always route right to the primary node in the active cluster that the connector is associated with. Read behavior can be configured differently, by default distributing reads the local cluster associated with that connector. However, this can be changed with the use of affinity and advanced routing methods. I do not cover those specifics in this course, however there is extensive documentation at docs.continuant.com that will guide you along with our support services as well. So what does a configuration look like for active-active? Well, it's very similar to the active-passive, very similar to a standalone cluster with just the addition of the extra services. So in this example, you can see we have the defaults with all of the typical default properties that we've discussed in our other training sessions. We then have the two individual cluster definitions. So we have the alpha cluster consisting of DB1, 2 and 3, and we have the beta cluster consisting of DB4, 5 and 6. And then we have the composite cluster global, where the topology is composite multi-master and is made up of composite data sources alpha and beta. So global is like the cluster of clusters, and global consists of alpha and beta. Additionally, with this being active-active, installation time, we will also automatically create additional subservices. This will make more sense when I show you in the demonstration, but each subservice created is a combination of the service names. So where we have alpha and beta, you would see a subservice of alpha from beta and a subservice beta from alpha, which handle the cross-site replication. And I'll show you this in the demonstration. So I'll switch my screens now and I'll show you an install and then show you what those subservices look like. Okay, so here on my terminal session, I have connections to DB4, 5 and 6 in this window and DB1, 2 and 3 in this window. I will just show you that the tungsten INI file, this is the same on all nodes, and it should be the same on all nodes regardless of the cluster that you're in. Will ensure you have consistency. So we will then go to our opt continuant software tungsten clustering 801 directory, and we will do the install, tools tpm install. Okay, and while that's running on these three nodes, I will also switch to DB4, 5 and 6, and I will run the same process over there. Tools tpm install. So the installation can take a moment or two, especially on an active-active topology. TPM, the Tungsten Package Manager, has got a lot more work to do. Obviously, it's got to build the properties files for the local services, and it's also got to build the cross-site services that I talked about, the alpha from beta and the beta from alpha. So you can see on DB1, 2 and 3 that is completed. Just wait a moment for DB4, 5 and 6 to complete. Once that's complete, we can then start the services and we can start looking at what the cluster control will look like. There we go, DB4, 5 is done and DB6 is done. So I'm just going to exit and log back in as the Tungsten user just to reload that environment, reload my paths, aliases and all of the kind of environment stuff that we set up. I could, if I wanted to instead, I could have run the source on the bash file as shown in the output here, but I just sometimes find it easier to exit and log back in again. Okay, so that's done. So I can now start all on DB1, 2 and 3, and I will jump to 4, 5 and 6, and I will also start all on here as well. What's important to note is the MySQL database on here is just an empty default install database. I don't have any data in it yet. If you are putting this into a system where you already have an application and you already have data running, there's a more complex route. The installation, the tools tpm install, is exactly the same, but obviously you need to provision those databases with data first, so you would need to hit backups and restore those backups. I don't cover that in this particular session. We do have backup and recovery training sessions which will touch on those processes, but if you're in a situation where you're looking to do that, please just engage with our support services and we can go through that with you, because every situation is different. It depends on how much data you have, whether you have a database that's in terabytes of data, whether you're already running native MySQL application and you're wanting to replace it with Tungsten. There are different steps for different scenarios. So rather than have a training session that covers all of those, if you just reach out to support and we'll be able to guide you and assist on a case-by-case basis. So start all is completed on 1, 2 and 3 and 4, 5, 6. So what we can do now is we can actually take a look. So if I go into cctrl, DB2 associated with the alpha cluster. So by default, cctrl takes me and connects me to alpha. And if I look in there, I can see we have the nodes DB1, 2 and 3. everything as we would expect. If I go over to DB5, cctrl associated with the beta cluster, and that logs me into beta by default, and from there I can see 4, 5 and 6. So within this, from this viewpoint, the cluster just looks like a normal standalone cluster. You have your nodes. Any writes written into DB4 will be handled by the local replication service, so 5 and 6 will pull that data across, apply it, no problem at all. So how does that replication flow between clusters? Well, I talked about these sub-services. So from here, we can go to global, and we can have a look at global, and we can see that what we actually have is we have alpha, which is the composite master, which is made up of alpha and alpha from beta. And we have beta, which is made up of beta and beta from alpha. And we have the alpha line is the master service for that cluster, and the alpha from beta is the relay. So within alpha, alpha from beta is pulling replication from the beta cluster, and beta from alpha is pulling replication from the alpha cluster. If you had 3 clusters, you would have another one of these X from Y services for each cluster that you have in your configuration. And we can look at those as well. So we can look at alpha from beta. And here we see the same as what we saw in alpha, so DB1, 2 and 3. But you notice here differently where DB1 in alpha is a master, DB1 in alpha from beta is a relay. And what that relay means is that this node is responsible for pulling replication from DB4, which is the primary in beta, applying it locally, and then feeding that down to DB2 and DB3. So the replication will flow from the remote cluster through the relay node and then down through the replication to its local replicas. And we would see the same on beta from alpha as well. And there we see that DB4 is the master in the local cluster. In this subservice, the relay, so that particular service is pulling that data across. Basically, that's all there is to it. When the primary node fails, if DB4 was to fail, the relay node would also move with it. So the relay node and the master node are linked, and they follow each other around. You would never need to worry about moving any of these around yourself. Everything that you do within a cluster should always be focused on the top level, the primary level of that cluster. So if we issue a switch, let's move DB4. Just take a moment for it to flush any transactions. It should be fairly quick because I have no data changes going through this cluster at the moment. There we go. Let's put the primary master. It's selected DB6. So DB6 will be my new primary node in this cluster. And DB6 will then also be the relay node within the underlying beta from alpha. So we can see it's synchronizing these subservices. It's putting the new relay, DB6, online, and the prior relay, DB4, is going to a replica node there. Okay, that's done. So if we do an ls, we can see that the role of primary has moved from DB4 to DB6. And if we look at the beta from alpha, we can see that role of relay has also moved. From a replicator position, if you're used to using the trepctl, so obviously in a standard cluster, you would do trepctl status and it would give you the status output for the local replication. In Active-Active, there are 2 replication services. So if you issue trepctl status, it will say, I can't do that because I need to know which service you're talking about. So first of all, we can say, okay, let's actually have a look at the local replication service. So trepctl service for beta. And we can see that DB6, obviously I did that switch. DB6 is the primary and DB4 and 5 are the replicas. So this is moving local changes. So this replicator service is only moving data changes that are applied directly to the primary node by your applications. Data changes that are applied to the primary node as a result of that cross-site replication, so from the other cluster, that's handled by the from alpha service. And if we look at the status there, we can see that DB6 here is the relay, and its source of data, its pipeline source where it's getting those changes from, is DB1, which is in that alpha cluster. Okay, so there we go. That's just a very simple look at how that replication flows. So back to our slides, and that's the end of this session. We looked at the active-active topology, we reviewed what it was, we looked at the config file, what it looks like, and considerations. Specifically, we talked about conflict resolution, or in our case, conflict avoidance, and there's best practices. And then I walked you through a demonstration of installing an active-active cluster and how to understand what the X from Y subservices mean and how to understand that output. So I hope you found this session useful. Thank you for listening, and I hope to see you again soon on another one of our training sessions. Take care, thank you, and goodbye.